Welcome back to the WNB Salon series. This has not happened for a long time, but we're super excited to bring it back. And I'm super excited about the fact that you have a better host today. Hamel Husain will be hosting today's session on AutoML. What does that word even mean? And how is it going to impact our lives? The awesome panel here will be discussing that, and Hamel will be leading this discussion. Hamel is currently building ML tools at Outerbounds. He's one of the 666 contributors of fast.ai, one of the core maintainers. Previously, he was at GitHub, Airbnb, and DataRobot. So he has a good amount of experience in AutoML tools and tools generally speaking. With that, Hamel, I'd like to hand it over to you.
Thanks a lot, Sanya. I'm really excited to be here to talk about AutoML. But first, I want to introduce the all-star panel that we have. So I'll start with Shreya. So Shreya is here. She builds systems that operationalize ML workflows and has conducted lots of research on ML systems, including end-to-end observability. She has done ML and software engineering at Google Brain, Facebook, and Viaduct, and is currently doing a PhD at UC Berkeley, where she's taking a deeper look into databases. And it's really exciting to have her here to talk about AutoML. Next, we have Zach Mayer. So Zach actually is the person that got me into data science. I was kind of just a, lost consultant at one point. And Zach is kind of like one of the people that came in and kind of showed me what ML and data science is all about. He's actually one of the core contributors to a package called Carrot, which is an R package, which is my first experience with something that felt like AutoML. It was really interesting. And it was a software that allows you to quickly try many different types of models and like a consistent API. And it was the thing in the time where there was this like classic ML, before deep learning. It helped to kind of make sense of that space. So it's really exciting to have him here. Zach is currently leading data science at DataRobot. Next, we have Ted Kwartler. Ted is a data science educator. He's also done a lot of work with applied ML, especially in insurance. He specifically works on fairness and bias in ML systems as well, which is a very important topic for AutoML. And I've generally found that Ted is really good at focusing on the business impact of machine learning. And he's currently leading this genre of work at DataRobot. Next, we have Robert Nishihara. He's a CEO of Anyscale, which is a framework that helps you scale and deploy ML, and which is built on the open source library Ray. He's also a member of RISELab and AmpLab at UC Berkeley, which has been the incubator of all kinds of cool technologies like Spark and Ray and other things. Next, we have Dan Becker. He's currently the VP of product at DataRobot, but before this, he founded Decision AI, where he built tools to help people measure and optimize the business value of ML. He's also the former head of Kaggle Learn. One of my favorite courses that he's made on there is a course about ML explainability. So I highly recommend everyone checks that out. Dan is also an economist by training, which is a nice perspective in a room of machine learning engineers. He's also the VP of product at DataRobot currently. So with that introduction, first kind of question I think on everybody's mind, I think this is where people get really confused in my experience, is like, what is AutoML? So like, for some reason, when I say the word AutoML, a lot of times people think that the scope of that is really small, that it's just hyperparameter tuning and neural architecture search. But for me, it's a lot more than that. So I kind of want to get everyone's thoughts, kind of go around and kind of get your viewpoints on like, how would you define AutoML? Like, what does it mean to you to start with? So, okay, we can start with Dan.
Yeah, I mean, it's interesting. You said you started by saying that to you, other people think that can be as small as hyperparameter tuning and model search, and I think you view it more broadly. I actually would I think there's a pretty broad range of AutoML systems, but if you had a for loop or something, a grid search in scikit-learn, and then you ran a for loop and said, I've got several different models, I'm going to try them. I would describe that as a pretty rudimentary AutoML system. And then there are others that are where AutoML, I think scaled up somewhat from that would be like Teapot, which is an open source Python library, but again is mostly like model search. And then there are other AutoML systems where you have model explainability that's built into it, and tries to be much more of the whole workflow. Some AutoML systems do have nice EDA functionality, and I guess I still call that part of, at least they consider that part of their system. So I think there's a pretty broad range, but I think it can be something as lightweight as having grid search and scikit-learn or neural architecture search. I think there's a pretty broad range of things that I consider AutoML.
Cool. What about Shreya? What's your take on AutoML, or how would you kind of characterize it from your point of view?
I think it's this vision that people are talking about where I have a data lake and I push a button and then out comes a model that's like perfect. And somebody else will do something to get it to this perfect model or perfect predictions. And maybe some people are thinking, non-data scientists, people who don't know anything about ML can now use AutoML and reap the benefits. Or maybe it's like the ML engineer who's toiling away can abstract away like all of the nitty-gritty feature engineering code that they have to do and get something great. I don't know. But I think it's this like larger vision where we just feel like we don't have any pain in developing ML models. That's very vague, but probably how I would define it.
Interesting. Yeah, that makes a lot of sense.
Hamel, can I ask a quick question?
Yeah.
Of the group, like, do you guys feel like the operation, is it just on ML dev, or is it also getting it to ML ops or getting it to, a secured endpoint? Do you consider that part of the AutoML perspective?
I think this is a great question because no research paper I've ever read in AutoML has the word ops or concept of ops in it. But somehow they're able to pick the like best features, do some end-to-end deep learning, and come out with this great model.
Yeah,
Just like part of the puzzle, but not the whole thing.
I think it's an important part of the story, but it's not part of the image that I have in my head when I hear the term AutoML. When I hear AutoML, it's similar to what Shreya was saying. I'm thinking of essentially a black box that takes in your data and then outputs a program or model that can do the machine learning, and you don't actually care about whether that's a neural network or a decision tree or how it works under the hood.
I was going to say, I think my perspective on ML is a lot like any kind of other automation. Hamel, you said I used to do consulting. Like that's when I learned to program, because I found myself doing a lot of repetitive work in Excel and thinking, man, I just spent 4 hours updating this workbook, and it sure would be nice if there wasn't a manual process I had to do every time the managing director showed up with a new set of numbers. I think programming is really exciting because in a lot of cases, when you're writing code, you're automating something to some degree that you used to have to do manually. So like I had a pretty good run at a couple different consulting firms of, turning Excel workbooks that took weeks to update into R scripts where you could just put in some new inputs and get some new outputs, and you were done. And so I think that's a lot of how I think about AutoML is early in my career with machine learning. There's a lot of really repetitive tasks of like, man, I'm just writing like the same code to take like some data and turn it into numbers that XGBoost understands, and then the same tuning, and then the same thing. It's like, I keep writing the same block of code over and over again. I should package it up in a function somewhere so I can just import my XGBoost pipeline and use it wherever I'm writing code. And so I don't know. That's very much how I think about AutoMLs. Is it's just you've been doing something manually and it's repetitive, and at some point you can teach a computer how to do it, and you can move up a level of abstraction and start thinking about bigger problems.
That's a good observation. And like one kind of sort of argument against AutoML, or some kind of objection that a lot of folks have is, or they get caught up in this debate of, hey, can AutoML replace a data scientist? And that is an interesting conversation. I think, like, I'm really curious what, if you've used AutoML, has it changed the nature of your work? So, I mean, I'll share a little bit about that. Like, AutoML has been really interesting for me to do things like get a really good baseline before I start working. Whether or not I use any models from AutoML or not, it's just really good to have a baseline. Another thing is, anytime AutoML frameworks can give me any diagnostics or any kind of information about what's working and what's not working, kind of like riffing on Robert's point. But like, some AutoML frameworks are like black boxes. You just get a model, you don't get anything else. But it doesn't have to be that way. Like, there's some AutoML stuff out there that gives you a lot of information. So I'm just curious, like, how everybody in the room maybe views AutoML. Like, is it really, can it really, like, is there any surprising ways in which it's like changed your work, even if you are building models? Even if you do it, like, build models the classic way, do you still use AutoML? Just out of curiosity.
For me, I liked Zach's description of, like, 5 or 10 years ago, we were operating at one level of abstraction, doing all these little details, and we wanted to have something that automates that. And now we're not so zoomed in on things because, like, code can do them. And so for me, I think it has changed my work from, I'm working at, like, really zoomed in, and I'm frequently like, oh, maybe this other hyperparameter can get my accuracy up by like 0.1 or can get my AUC up by like 0.001. And instead I'm saying, like, what's the target that I should be predicting? Which is, like, actually the thing that has a 10x or 100x bigger impact in reality on, like, am I producing something useful? But by automating the pieces that are tempting to look at, much like we're all tempted, like, we watch our deep learning models, like, train, you watch that little loss curve, like, that's not a good use of our time, but it's so tempting. And in the same ways, like, I used to get pulled into little details, and by automating those away, it doesn't replace the need for a data scientist, but it allows a data scientist to think about, well, what should I be predicting? How should I be validating it? How am I going to want to deploy it? Do I really believe that whatever accuracy I saw in training, like, it's actually going to have that in the future? Or do I think there's going to be some sort of drift? Is there some way I can change the problem so that I think there's going to be less drift? Like, these are more abstract questions that we're free to think about when we don't have to be bogged down by, like, what's a better learning rate, or, like, what's the better learning rate cycle, or some other, like, complex detail that doesn't matter that much.
I actually agree, Dan. I think project scoping is super important, right? And this allows people to spend time on the project scoping and thinking about these systems. And really, unless you're at some massive scale of some large, extremely large enterprise, or optimizing to the last nth degree is not necessarily the best use of your time. So I think that it does free up the capacity to think holistically about the impacts your models are going to have. My work, we talk about modeling bias, so think proxy features. How do we inadvertently pick up race, gender, stuff like that? If you're moving fast and trying to just optimize, like, you could end up bringing in proxy features because it increases, the AUC slightly, right? But you haven't thought holistically about it. So I think it does free things up. And I think the other thing I would say is not all data science projects are made the same. So, for instance, like, if I actually do think that there is a group of use cases that are, let's call them low risk, that I think an AutoML system could replace a data scientist, and where you could get a less experienced one, and that frees up the data scientist to, again, work on the maybe higher impact or higher risk models, because I think that's where we want to put our attention. Right? I think the pushback to me, though, is that data scientists love the model building, right? They go to school and they learn KNN with Iris, and they learn logistic regression with Titanic, and they're like, this is amazing. I've unlocked a puzzle, and building the model is the exciting thing. It's like, no, it's not really the exciting thing. It's the impact you can have to the business, to the organization, or otherwise.
But it's sorry, jumping again, but Ted, like you say that, it's funny because Hamel brought up the carrot package, and like I remember the first time I discovered carrot, it was, I think I was trying to do a KNN model in R, and like I couldn't figure out how to make it work because the problem with R is every single package has a different interface.
And
like
syntax,
I was reading, and like carrot just showed up and was like, hey, Max got annoyed with the same problem, so he just wrote a package that unified the interface of all the models. And so it's funny, like that's kind of like, I look at that as, in a lot of ways, the start of my journey to AutoML. It's just like, I am not good at remembering details and figuring out how to make a KNN model work versus a linear regression model work. Like that's not something I'm good at, and I don't want to be doing it.
Right.
Yeah, the black box that Shreya described, being able to really just push a button and get your model, that is, while that's incredibly useful, and that's pretty ambitious project, it's far smaller in scope than fully replacing data scientists. I think fully replacing a data scientist, there are many other pieces to that, and things that data scientists do around scoping the projects, asking the right questions, and that outer loop around training models. The way that this has impacted the tools that I've used, it's not so much that one day I switched from using, doing all the low-level hyperparameter search and everything to just having a button to push. It didn't really happen that way. But machine learning has become a lot easier to apply over time. I think there are things like, it used to be very hard to get neural networks to work. Everything from, we have better techniques now for initializing neural networks. We have better model architectures. It's not just searching over defaults or searching over different options. It's also just having much better defaults that to start off with. And so, even without getting all the way to fully having the black box, there's been a lot of progress on making it easier and easier to apply.
I love making web dev analogies, so I will make a web dev analogy here. I think with any technology, if implemented correctly, you will see more data scientists or more people of that role come in and, do what they're supposed to do. When React came out, when even website builders like Squarespace and whatnot, you don't see fewer web development engineers or front end engineers. You see people of different backgrounds join the discipline. The barrier to entry is lowered, right? If done correctly for AutoML. I think we're in a unique point with AutoML where the barrier to entry is not lowered. It's very odd and weird. We have all these custom packages in scikit-learn or in R or whatnot, where you don't need any extra, or you don't need less. How do I say this? You still need the same amount of domain expertise to do it or to leverage it. So I think it'll be really cool once we're at that stage where people who don't really know how to program can, all of a sudden be building ML models. That's a super far off pipe dream. But
that's the goal, right? To have this in data science in everyone's hands, diverse set of uses, right? Diverse set of perspectives on building. Sure.
Yeah, I'm told that historically, the early versions of what we now call compilers were called automatic programmers, because they basically translated from, I think the first language where that was called was Fortran, but they created assembly code from something that was higher level. And it's funny to think now, if we'd never had compilers, if we didn't have Python or any high level languages and we were all using assembly language, would there be more programmers or fewer? I don't really know. I just know computers would be way less cool because there would be a lot less software. And I think that we'll probably get to a point where the same way we can now use high-level languages and say we're programming, will someday be that at that place with things that we now consider AutoML. We'll be like, oh yeah, that's just doing data science or machine learning.
I'm really curious, like Shreya's observation about people that don't know how to program but still leveraging data science. So to ask a kind of pointed question, is that what data is, like something like DataRobot? Does that supposed to allow that? Yes or no? Like, what is your?
I'm not the
experience?
data robot.
Oh no, I'm not. I'm asking the room. I'm asking the whole room. Like, I'm asking the people here from DataRobot, just because it's like interesting to me. Like, what's been your experience there? Like, from interacting with people using that, has it come to that point? And tell me something about that. Like, you must have experience with that.
My observation. I mean, Zach, Dan, jump in it. But my observation is it's dependent on like the organization and the data fluency of that organization. So, I know a guy, he's a government relations guy, he's not data fluent. 2 days in a DataRobot class, he now knows how to build a model, right? But does he really understand like what the use case could be, or is his mind open up to all these different projects? So I think some of it is data fluency and culturally of the organization. And the other thing is, yes, a system like DataRobot will lower the barrier for people who already kind of have that cognitive aptitude or that are aspiring to be kind of, like some of the people on this panel. But I also think that organizations underestimate the state of their data, right? And that can be another barrier so it's not just the people, it's also, do you have the data? Is it organized in the way that you think it is? Do you have a version of the truth, right? You might be measuring it in 3 different tables differently. I think that those things are important. And those have been some of the barriers to having this kind of utopia of like full data science. It's a total abstraction. I just click a button, right? So I do think some scaling on education helps, and systems like DataRobot are moving in that direction, certainly. But I think also the underlying data is so varied. And a lot of these architectures and systems were built, a decade ago, right, or longer, and so things change in terms of what they're housed in and how they've been measured and things like that. So
that makes a lot of sense. Like, yeah, I would be. It seems like you still have to bring your data to the AutoML system, and it seems difficult to do that without any programming of some kind.
Yeah, like when I was at the insurance company, we would be doing like auto premium, and because that's so important to the insurance carrier, we'd have a team that would say, we've gone into the data swamp and we've figured it out, and this is the data that you should be modeling, right? So it wasn't even, because they didn't want us spending that time doing that data munging, and then we all kind of have a different version of the truth. They would help curate that for us. That was the state of what we had to work through, I would say.
Makes sense.
Yeah, I mean, my sense is, first of all, you need, like you said, you need to get the data in shape. That can be done with visual data prep tools, like Alteryx. Can be done in SQL, which I consider coding, but maybe some people don't. But it does require a lot of effort to get the data, to get your data even at the state where it can enter today's AutoML systems. Like, we're working hard to lower that bar so that we can take data at an earlier state, a DataRobot. But I think it still typically requires some effort. And then the other half is okay, so programming is hard. It takes years to learn, but also figuring out what is an important machine learning problem and figuring out where are the API for a machine learning model is not .tell me what to do. It is .predict. And so to figure where are predictions useful and what would I do with them if I had them is a problem which I think even fewer people know how to solve than know how to do programming. And so I'm actually a little less optimistic about the future where there are 1 million people using machine learning for practical purposes. And I think AutoML tools, DataRobot included, are useful in that direction, but I don't think that we're getting close to the world that Shreya described up front, this world where a lot of people are ready to use machine learning, because even if they could build the models, for those models after you've built the model, if you're not in a Kaggle competition, you're sort of like, oh wait, am I supposed to use this for something? And I think that part is still pretty hard, and we haven't figured out how to automate that.
Yeah, I call that last mile delivery. What's that last mile to get to just even a simple web form where I can click submit, right? Because you could be a data scientist and it's in a Jupyter notebook, but that only gets you so far, right?
But I think there are two parts of that. When you say it's in a Jupyter notebook, now that's the upside. If you say maybe it's a model that can be pickled or exported to Onyx. Now I bring it somewhere. Now I've got a RESTful endpoint.
Yeah, there's still something else. There's still there's still a mobile app. There's still deliver some value to the organization or to your community, whatever you're building for, right?
Yeah, and part of that is technological, but part of that is like, what even conceptually could these predictions, why could they be useful for? And I think there are many cases where we have had so much excitement around machine learning that people build machine learning models and they're like, actually, I have no idea what I would do with that model, even if I could get it like operationalized. I just built it because like machine learning is cool.
There's definitely a lot of that going on, for sure. Okay, another question, another kind of thing I want to pose to the panel is, so there's some like criticisms of AutoML that are commonly put forth. So like, I'll just list some of them. One is it's computationally prohibitive, is one view. And another one is it lets people do ML that don't know what they're doing, thus encourages like bad practices or sloppiness. Another kind of criticism is it takes away the most fun aspect of ML, which is building the model, which is not the most fun aspect for me, but people do say that. Another criticism is like there's no way it can beat a human being. There's just no way. That people just have that baseline skepticism. And then the last one that kind of comes up is AutoML just overfits your data by mining it aggressively. So I mean, it would be interesting to get some thoughts on that.
I mean, I've got a really strong reaction to that last one, which is I've worked in consulting for years where we overfit the data by mining it aggressively manually. And those consultants all made fun of me for going to an AutoML startup because they're like, oh, you're going to go work at an overfitting company. I was like, you can, like, for example, cross-validation is something you can program into a computer, but it's hard to program into a human. And so like, that's the one that I really push back on because like humans are very good at overfitting and fooling themselves too. And yes, you can program an AutoML system to overfit a data set and that does happen, but you can also, if you're thinking about your problem and framing it correctly, you can program an AutoML system to be honest about how well it performs on new data.
One kind of like leveraging that question, I'm just this is kind of funny, but like when we talk about human biases when it comes to ML, one thing Zach, you and I joke about all the time is like bag of words, like how good bag of words performs.
Right, I literally changed my Twitter bio to be like, "Have you tried bag of words?" Yeah.
So can you expand on that a little bit? Like, what is behind? Like, just like explain that.
So riffing a little on what you said, modeling can be fun, and it's not always the part that I find fun, but like fiddling with the numbers and watching your loss get lower and watching your learning curve. Like, I don't know, there's a whole genre of video games called idle miners that I just love, where it's just you're watching a number go up basically, and there's something that's kind of fun to be like, oh, the number's bigger today, like that's great. And so I don't know, I've lost my train of thought because I got so excited thinking about video games. Can you repeat the question, Hamel?
Oh no, so I was asking to explain the humor behind the bag of words thing.
Yeah, right.
And so about AutoML and all that stuff.
Text is an area where there's just an explosion of research right now. There's all kinds of really, really exciting new stuff in text right now. If you're starting a new problem, it's just way more fun to go straight to the state of the art and say, I'm going to do, a deep learning attention-based model that's going to do all this crazy stuff and it's going to understand every language that's spoken, and it's just going to be awesome and spend a whole bunch of time doing that because that's really fun if you're focused on the fun of building models. And the flip side of that is that like there's a lot of text-based problems where just looking at the words is probably good enough. And like one that comes up all the time that I really like automating is like classifying tickets in some kind of ticketing system. Like a customer comes in and says something, and you're trying to say, is this a feature request? Is this a bug report? Is this someone asking for technical support? And like very frequently, you don't need a deep learning model or anything crazy and sophisticated. You can just build a very, very simple system that like looks at the words in the text and says, geez, when people say the word error, it usually means they have a bug report. And when they say the words, it would be nice, it means they've got a feature request. And when they say the word help, they need help. And that's the level of automation you need, is just a computer that just says every ticket with the word help in it, send it to the tech support people who can call them up and give them help and like help them write better code or whatever. And, every ticket that's a product request, send it to a product manager, and every ticket that's bug report, send it to engineering, and, you're done. And, importantly, the cost of misclassification there is low. Like if 10% of the time you're misclassifying, a bug as a feature request, it's not hard for the engineering team to just say, this is actually a feature request, send it back over to the PM.
So
I think I don't know, text is especially one where it's like, and I believe this anywhere, like in any job I've ever had, and maybe working consultant kind of put this mindset on me, but like always try the simple, easy thing first. And if that solves your problem, don't worry about it and move on to the next problem, because there's always more problems to solve. Like getting bogged down in the perfect or most exciting solution to something, like start simple. And if that doesn't work, go more complicated. And AutoML systems are really good at that. Like especially with text, an AutoML system will tell you, hey, bag of words works great on this problem. It's simple, it's explainable, it's fast, you're done, move on to the next problem.
Yeah, I can't tell you how many times I've reviewed a problem, because as data scientists, we want to get excited about the state of the art thing. It makes you can sell your work a little bit better. It's more exciting to talk about, so on and so forth. But I can't tell you how many times I've been surprised by throwing an AutoML system at a thing that's using a transformer and saying, oh, wow, this bag of words model is giving me really good results. So it's it's an interesting way of keeping things honest in a sense.
Right. I mean, this happens to us at DataRobot. We get customers who show up and say, we need named entity extraction and sentiment analysis and like this long list of like specific technologies they've got in text. And you'll ask them, well, so what's the problem you're trying to solve? I'm like, well, we're trying to classify documents. And it can be sometimes like, well, have you just tried bag of words, which doesn't have all those technologies in it and is way less effort to implement. And, DataRobot and a million other systems do it well, but anyway.
Makes sense. And so about these other criticisms of AutoML, just throwing it to the panel, what is any of those criticisms resonate with you, or what do you think about that, or what's like?
I mean, I think a lot of the criticisms are criticisms not of the goal, but of the state of AutoML today, right? They're saying it's hard to do well, and it is hard to do well, but of course we'll make it better and better over time, and we'll get there. So I don't think there's that's sort of my reaction to a lot of the criticisms there.
I take issue with that human can always beat AutoML because my experience, like the first time that I saw DataRobot, I was gambling on basketball, and I spent a lot of time on my model, a lot of time on my model. 30 minutes into DataRobot, a NiStream kernel SVM one, and I said, I don't even know what that kernel is. So cool. I guess I spent 6 months building a model that is now worthless. Now, it's not to say that, like, obviously you guys that are better data scientists couldn't beat it, but I think there are times it doesn't matter about beating it, because what is it to beat it? To Zach's point of, like, solve the problem as well as you can and move on to the next problem, right? So I think that there's a value in that as well. And to beat a model just by saying 6 decimal places out, my log loss is improved, I don't think is really the right framing of how do you contribute to the field.
Shreya, I think you have.
Yeah, I mean, really want to echo Robert's point on the state of the AutoML, and then also Ted's point. I think there's this interesting culture that maybe is taught in academia or in classes that you should try to eke out as much performance as possible. You should try all the architectures. Feel bad if you haven't exhausted every architecture, so you know that you're getting the best possible performance on some, I don't know, holdout set or whatever cross-validation you want to do. One of the projects, but this is weird, and I'll explain why. So one of the projects I'm working on right now is an interview study of ML practitioners. And specifically, the big question is, how do you feel confident in your models when you're deploying them? And most of the more mature organizations are saying we have this dynamic evaluation set, we have this eval notebook or something, and we just keep adding examples to it as we see examples fail in the wild, something that's always changing. So it doesn't make any sense whatsoever to try out all the hyperparameter combos, because tomorrow is going to be different when this evaluation set changes. Do you use AutoML is a question that we ask these people, and they're yeah, to inform good model choices or things about our data, but not to get the best model selection or hyperparameter selection or something like that. And I think that's super interesting, right? This, how do we move away from the culture of just trying to beat performance for performance sake and create something sustainable?
I also, Robert's description I thought was really good, and it reminded me when Google Cloud first came out with AutoML, to run AutoML, they did everything with neural architecture search, and you could be uploading a Titanic data set. It would cost more than $50 to run it, just to run a training job, and it would take several hours. And that was the case for, I think, months. And then they said this is not good, and they replaced how they did model selection. And now it probably costs, I don't know, $2 and runs in minutes. And that's just the nature of progress. Is AutoML now is not where it's going to end up. And I think that's exactly what Robert said. I think there are plenty of examples of it.
How important is in AutoML? So there's definitely this genre of AutoML that is a black box, like Google Cloud, product. You kind of upload your data, you get a model, you have no idea what is going on. Maybe you don't care. What, in your experiences, how important are the insights in AutoML? Some AutoML systems provide a lot of diagnostics, a lot of, things that maybe, some people use even more than any models. Just to curious, have you seen that? Is that, what's your thoughts?
Yeah, I think that's super important. I like the data quality checks that happen, things like target leakage. I think a lot of newer data scientists may not know how to check for that or what that looks like. Obviously, my team, I know I'm partial, but we do a whole thing on bias insights. If you declare a protected feature, and we'll help you understand maybe cross-class disparity or what is the proportional parity, things like that. I think there's real value in understanding your data set as quickly as possible and the flaws therein or the things that might be super valuable in the modeling, even if they end up modeling elsewhere. So I do think there is value kind of in that auto EDA, or more even using models and getting insights for explanatory purposes, I think is important.
Yeah, I think it varies quite a bit from one project to the next. But one of the concerns with AutoML that I said earlier is even if you had the ability to build machine learning models very easily, frequently you're okay, but now I have a way to make predictions. Ooh, why do I care? What do I do with them? And I see it. I mean, this isn't unique to AutoML. This can be done with, regular Python libraries that don't call themselves AutoML libraries, but to get permutation importance, there are a lot of problems where just understanding what are the factors that most impact churn is actually more if I said this person is 4% likely to churn, this person is 7% likely to churn, this person is 6% likely to churn, I think you could very easily say okay, but what are we going to do with that? Where if instead I said people who bought something online instead of in store are less likely to churn, now you're starting to get to something that's actually actionable and a person can make better decisions with. And so I think there are a lot of projects where the insights are actually the deliverable or the thing that matters. And the way that we typically think about operationalizing ML and deploying it and getting predictions isn't so critical.
Yeah. I mean, I think permutation importance is such a great example, Dan, because like in theory, I know how to program that. In practice, I never have, because it's just like, it's kind of annoying to get it right for every different model you're working with. And like, I basically just use AutoML systems, even if I write my own code, to just say, okay, like here's a data set, here's a function to fit a model. Tell me what variables this model thinks are important in like a model agnostic way that I can compare across models is really, really useful. And that's a nice thing to have automated, because it's annoying to do it by hand.
I really like the point, or go ahead.
Go ahead.
I really like the point that sometimes the insights are actually the deliverable. I think that's really good. One thing I'll add is that when the model, in the cases where the model is actually the deliverable, the importance of insights sometimes comes down to just how well it works, like how well the AutoML works, right? If it really just nails it, you may need less insights. And but of course, if it doesn't do exactly what you want the first time, then there's going to be some outer loop of debugging or improving or tweaking things, and then you're going to need the insights in order to make progress there and to understand what's going wrong. Like if there is something that's going wrong, that's when you need to be able to look a little bit more under the hood.
Yeah, there's actually, I just want to call our attention to, there's a question in the chat that seems relevant to what we're talking about, which is how do you address misalignment between the model prediction and human intuition to a non-technical stakeholder? Is that the current limitation to put neural networks into production? And I mean, I think you just totally answered that question, which is when you see misalignment, that's where it's so important to go look at some kind of automated insights from the model and say, here's why the model thinks this is the case. And you'd be like, oh, well, that's obviously wrong. The model's not correct. And now you need to update the model, or the flip side of that, which is like, oh, interesting. The model has discovered a relationship that makes sense that we didn't consider when we judged this as a human.
Yeah, I know there's human resource systems that are doing document classification, and they are so they have like a human reviewer, and there's a recommendation that comes with it. But you'll want to hold some of those back and look at that human and machine alignment and understand when there's disagreement. And it could be a flaw of the model, it could be a coaching opportunity of your human reviewers. Maybe they have an unconscious bias. So I think absolutely it's important, and it's hard to earn the trust of non-technical stakeholders. But for me, it's not saying here's the average prediction. It's here's how it can go wrong. Here's a very high prediction. Here's a very low prediction. Just like you, a non-technical person interviewing someone doesn't ask for their CT scan of their brain, right? They just interrogate the person, right? They ask questions of the person, right? And so like, if I get handed Zach's code, I literally probably could not understand it, right? But I can interrogate a model and get provided with counterfactuals and highs and lows, and where does it go wrong? Where's its region of uncertainty? Those types of things help me earn trust in that type of model. And those can be, you don't have to do that through an AutoML system, but those types of interrogations can be made to be easier to get a lot of that out in the right type of system.
Yeah, I think of going back, the question is addressing misalignment between what the models learned and what a human's intuition. I think of that as like the best case scenario is when that happens, because that's our chance to learn. And it could be that the human's intuition is wrong. Mm-hmm. And in most cases, like that requires doing some analytics and showing them like, hey, you thought that people who had X would have a higher churn rate, and actually it turns out that's not the case. And maybe we could even break that down, which is like simple statistics, which is frequently going to happen outside of AutoML. Like that's a chance for the human to learn. Or if we have the right ways of interrogating the model, like Ted was talking about, then we can learn something about, right, maybe you were missing certain features, so we wanted to interpret a certain feature as like a causal impact, and it showed up as having high permutation importance, and the partial dependence plot went up sharply, but actually it's a proxy for something else. And depending what we're going to do with the model, like that could be super important. And so it's when you get these misalignments, like that is the opportunity to say there really is something wrong about at least one of these two, and that's our chance to improve them.
Yeah. So we talked about like ways. It sounds like there are ways that AutoML can make data scientists, like augment data scientists and help them be more productive by giving them insights to models, baselines, so on and so forth. My observation is, like, some interesting observation, at least from my experiences, like, for some reason, like Silicon Valley type tech companies have not, like, I don't see really any AutoML happening there, versus, let's say, Middle America or even East Coast. It's like a strong resistance to it in a lot of cases, in kind of like tech companies, wanting to do things from scratch, like, the whole way. So first question is, do you feel the same way? And second, like, does anyone have any ideas of why that might be, if you do share the same observation?
I'll tell you my view, which is, so actually, last Friday I was talking to someone who works on a product at Google. She's doing basically identifying what messages through a bunch of different Google channels are likely to be phishing. Just building ML models. So that team does nothing but AutoML. And it's like they've got a problem. They found that it is easier to operationalize if the models all come out in a consistent format, and it's easier to deliver that with some AutoML technology. And so they use AutoML. I worked at Kaggle after it existed for 7 or 8 years. The people at Kaggle really do care about machine learning. And yet we existed for 7 or 8 years before ever having a machine learning model that was actually part of like how Kaggle works. And then they wanted to do some automatic moderation in the forums. They thought the easiest way to do it was to build a model with AutoML, and so that's what they did. And so I think there are people who are savvy enough that they just want to make things easy, and they don't feel that they need to try and make things hard for themselves to impress each other. And I think that group is frequently trying to use AutoML. And then you've got a group which is probably most startups, who take pride in their ML skill and don't want to use AutoML because it's not that impressive and you feel like you're taking the easy route. And then I think there's probably the other side, which is actually sort of like that meme of the IQ where people on the ends are using AutoML. But I think that the people who are trying to make their lives easier because they just feel like this is not our core competency, they also are finding AutoML appealing. But it's that middle ground of people who say, like, we're proud of our ML skill and we're willing to sacrifice productivity to show off, are the ones who are going to find AutoML least appealing.
I mean, that sounds a lot like the not invented here syndrome. Like you see that all the time in tech. Like you've got a piece of technology, you really want to do it yourself because it's fun to build something. And sometimes the most productive thing to do is just grab the off-the-shelf thing that does it for you and move on.
This is super interesting because I feel like I've had a different experience with AutoML in that I found that it works well when your infrastructure is very solid or robust, when you can trust all of the data, you can trust the pipes going in and out, your data is produced consistently, somebody's owning it. If something goes wrong, there's somebody upstream you can bug. But like whenever you don't have that, AutoML will deliver different things every time, or you'll be confused or curious, why isn't my model working? And there's this tendency to blame it on, I don't know, what you last did or the most complex piece of your system, rather than like maybe it's just the plumbing that doesn't work. And these like FANG companies and bigger companies, right, like have the plumbing nailed to a T. Like they have like 5 data engineers for every pipeline that exists. Anyone is on call any second of the day. And I don't know really how to bring that culture to all of the Silicon Valley kind of data startups.
My experience was pushback to an AutoML system by pointing out everything it didn't do. And of course, any abstraction will just have limitations. Like despite Zach and Dan's best effort, they're not able to build everything into our app, right? So they get into these corner cases and they say the whole system's flawed because it doesn't do this, these GANs. It's like, yeah, but are you ever going to use them? Do you ever need them? Like, what are we talking about here, right? Are you going to actually deploy that, right? And so you get kind of into that perspective. I don't know where it stems from, but that was like a real experience that I had. I know someone who was part of the evaluation team for an AutoML system, and I'm not joking. she was a brilliant data scientist, PhD, amazing data scientist, and she clicked on every single button within the system and documented everything it didn't do, not necessarily everything it did do. Right?
Robert, you're saying something?
No, I don't know if I have any special insight on this particular topic.
No, that's totally fine.
I had one more thought, which is just, education is valuable too. And there's a certain degree to which building something yourself, you learn how it works, and that helps you become better at it. And I think if you look at it through that lens, there's an opportunity for AutoML, which is, hey, if AutoML was better at explaining itself to you and saying, hey, when you use XGBoost models, one hot encoding is actually really bad and ordinal encoding is really good, even though that's super counterintuitive, and here's why. Now you know something, you've learned something, and the AutoML system just doing it for you, like, that's valuable, but telling you why it did it and helping you, learn more data science is valuable too. Like, the educational part of it that you get from figuring out yourself, does have value.
I'm glad you said that. Like, one of my earliest experience with AutoML, so like when I was working at DataRobot, I remember this one conversation. So DataRobot, like, they have this, when you evaluate your models on a holdout set, it's hidden behind this. It's obfuscated. The holdout score is obfuscated, and you can only look at the holdout set after clicking through some buttons, and it like warns you, are you sure you want to look at the holdout set? And I remember when demoing this to a customer, they got into, there was a debate, like, why is there so many clicks to look at the holdout set, and why shouldn't I just choose my model based on the holdout set? And this actually conversation happened tens or hundreds of times, which is really interesting, kind of like with regard to the education perspective. There's some things that I feel that could be automated that help people learn, but that was surprising to me. Like, a surprising aspect of AutoML. Is there any other surprising things that you find with people that are using AutoML in practice? Like, that when they first start to use AutoML, you find like people learning certain things or doing certain things, that are like, let's say, counterintuitive. I'm just curious, like, what you see out there. I see the wheels turning. Everyone's head.
I think the use of it for experimentation, that it doesn't always, like, if you had the ratio of how many AutoML projects are kicked off versus how many make it to production, that unbalanced aspect of it was something I really wasn't. I mean, I guess I shouldn't have been surprised, but I was surprised, right? You might have a typical data scientist before AutoML or coding up manually. They may spend 6 months building a model and various models with tuning parameters and so on, and then maybe get one into production, right? And then just observing that in an automated system and like seeing that huge discrepancy, because when I learned about it, it was like all textbook cases, and it's like, yeah, of course this seems to be the best model, so that would be the one we'd move forward with, right? And then the next week you learn a new modeling type or whatever, and that's the next best model, right? So that was something that I found surprising, that experimentation to actual production, that drop off is huge.
One sort of question I have for both Robert and Shreya is kind of like in the academia research realms. What's like the state of AutoML? Is there any interesting work going on there that you know of? Just out of curiosity, like anything, that comes to mind?
Shreya, you want to start?
Nothing super new in particular. I read a couple of surveys. People are recently starting to think about how your AutoML configs change as you deploy your models in production. So like nature of like learning from new data, incorporating active learning into these AutoML systems and so forth. But it's not my area of research, so I could be very vastly wrong. Maybe yesterday, like something awesome came out on Archive, and this field moves too fast. I can't keep up.
Yeah. I think one interesting area is around cost, making things more efficient, making things cheaper, especially, if you're running tons and tons of experiments, they're all using a lot of GPUs. I think some of the exciting results have been around, being able to conserve resources by stopping experiments earlier, being able to invest more resources in the better performing experiments and things like that. I think there's still a lot of low-hanging fruit there. Another, interesting kind of difference between how I see some of the AutoML research or hyperparameter research in academia versus in practice is that a lot of times when people talk about hyperparameter search and tuning and things like that, it's about the discussion is around how to get to the absolute best possible performance, how to really, eke the last few percentages out. Whereas in practice, a lot of hyperparameter search and tuning and a lot of this work is around just getting something to work at all, making sure that you're not, wildly misconfiguring something and just seeing if the technique is plausible. And so that's one difference I've seen.
And that goes back to, I think you were talking about like good defaults earlier, just having libraries that set things up in a way that they'll tend to succeed the first time you try them is so important. And that takes time to learn, what are good defaults for neural networks? That's a whole area of research. There's that, I forget who it is. There's one guy who's published 3 papers that I love, and I can't remember his name now because I'm terrible with names, but they're just all about how do you actually make the model work well. I think he's one of the guys who first published about cyclic learning rates or something.
One other thing that I think is interesting is different programming languages and ecosystems make people more or less likely to use AutoML tools. Python is very, very ML rich, and you can very easily prototype a lot of deep learning, whatever you want in Python. And I've noticed that, at least in the interview study, that people who are more familiar with Python are less, or use AutoML techniques less than R or other programming languages.
That's really interesting. I have to read more about that. That's a little bit counterintuitive to me in some ways.
I think it makes sense from the lens of if I can build you a model tomorrow or try out 15 models really, really easily, I might as well do that. I know how to do it. It's mindless sort of philosophy, but I don't know.
You can write a for loop like Dan said. And arguably that is a kind of AutoML. It's just easy to roll it yourself in Python because all the libraries have the same interface, which is really nice.
Yeah, totally.
I guess I'm just super lazy. I don't even want to do that.
Honestly, this is I really love Python too and scikit-learn, but I think there's a future for AutoML, which is really cool. I think Teapot is getting a little bit there, but if AutoML can output a scikit-learn pipeline, people get that, they understand it, that's something you can fiddle around with. And I feel that strikes a good balance between, I've automated it, but then I can still fiddle with it afterwards because I understand all the parts in the scikit-learn pipeline. They're easy to comprehend.
Cool. So it looks like we're getting into the end of this discussion. Just in case anyone wants to say anything, just want to give people opportunity. Otherwise, we can say goodbye.
Yeah, I think there's just a lot of the interesting challenges, or some of the bottlenecks are around moving to production and really, like we talked about, once you train the model, integrating that into an actual product or integrating that into another application that you're building. And there's a big software engineering component. There's a big, infrastructure component, and a lot of these things are bottlenecks as well. That, in addition to the algorithmic side.
Makes sense. So it was really great to kind of hang out with all of you for this hour to talk about AutoML.
Thanks, Hamel.
It was a really cool conversation.
Yeah. Thanks you,
so
Hamel.
much.
Thanks for hosting.
Yeah.